All right, now we are looking at section 4, using the quadratic formula. Now right here at the beginning it says, now that we have completed the square, we can derive, and to derive means to make the quadratic formula. Now I'm not going to do that on the notes packet here, or on the notes video here, but we can, and there's all kinds of videos, there's good videos. If you want to see that, you can Google just something like derive quadratic formula, and it'll have it. But here we have the quadratic formula right there. And what we did, or what I would do in class, is I'd show you us starting off with ax squared plus bx plus c equals 0, and then I would complete the square using just those variables. So like in the last one, we completed the square using the actual numbers, right? We had b over 2 squared, we plugged in the -9 right there. Whereas whenever you derive the quadratic formula, you just use the variables, and it ends up giving you this equation right there. Now this is normally one of those things that people try to memorize, and I'm going to say that you should probably try to memorize that. There are lots of different videos, different songs that it goes with that might be useful. Right here, quadratics can be used to model projectile motion. The formula h of t equals -16t squared plus v naught t plus s naught models an object with initial velocity v naught and initial height s naught. There might be some homework problems that I assign that have some problems where they'll say, you know, the initial velocity is 5, the initial height is 20, and you have to plug into this formula, and then it'll tell you what to do after that. This bottom part here, if an object is dropped but not thrown, the initial velocity is 0. So we can use the simplified formula without the v naught t term, right? It's gone. It's not in the middle there, right? That just is zeroed out. So again, this formula here might be used in some homework problems. 21, we want to solve the quadratic formula. First off, we look back up, and for the quadratic formula, we have to have them equal 0. So I'm going to add this 1 over. We're going to have 3x squared minus 5x plus 1 equals 0. Now we'll have a equals 3, b equals -5, and c equals 1. Now let's copy down the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And again, that's something that we need to try to memorize. Now we just plug in a, b, and c. So we're going to have -5 plus or minus the square root of -5 squared minus 4, and I can't scroll my tablet here, minus 4 times a, which is 3, times c, which is 1, all over 2 times 3. That's my a value. Now we try to pretty that up. The -5 is a +5 plus or minus the square root, and then we're going to type this next chunk in the calculator, and it should give us 13 all over 6. And that's actually going to be our answer right there. The root 13 can't break apart because the 13 is prime, and the 5 and 6 are just going to hang around there. The plus or minus, make sure we got the plus or minus written in there. But that's our first problem there. To me, the quadratic formula is the easiest one. I remember being a student and liking the quadratic formula most because it was very consistent and you knew exactly how it worked every single time. Moving on to 22. Again, we want them equal to 0. I'm going to subtract 10x, and I'm going to add the 10 over. Subtract 10x, and then also add the 10. So that's going to give me x squared minus 6x plus 10 equals 0. Now I write down that a is 1, b is -6, and c is 10. Like before, I'm going to copy down the quadratic formula. X equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And then plug it in. I've got -b out front, so it's going to be -6 plus or minus the square root of negative 6 squared minus 4 times 1 times 10, 10, all over 2 times 1. Now, prettying that up, I'm going to have 6 plus or minus the square root, and this is going to give me a negative 4 under the root. Now, what I normally suggest to students is that they type this part, the piece under the root, which we're about to call the discriminant, but type that part into the calculator. Over 2. The square root of negative 4 is going to be 2i, so 6 plus or minus 2i over 2. And then because everything is even, we can reduce. The way that I think about this is we have 6 halves plus or minus 2i halves, right? I kind of break up that fraction. 6 halves is 3. 2i over 2 is just a plain old I. And that's going to be our answer there. We have 3 plus or minus I. Now this chunk down here talking about the discriminant, the piece under the root, the b squared minus 4ac, that's called the discriminant. And it can be used to decide really quickly how many solutions we have. So we have, whenever he's positive, it has 2 real solutions. That would be like up here. The discriminant was 13. So 5 plus or minus root 13 all over 6, that's 2 separate numbers there, right? You could type in your calculator 5 plus root 13 divided by 6, and then 5 minus root 13 divided by 6, and you get 2 different real numbers, 2 different decimals. 22, the discriminant was a negative 4. That was a negative number, that's down here, negative number, which gives you 2 imaginary solutions, 2 numbers with an I. And then you also have whenever he's 0, and that just gives you 1 real solution. So your answers are 2 real, 1 real, or 2 imaginary. Back when we did this in Algebra 1, we had a similar idea right here with the discriminant, and we said 2 real, 1 real, and then 0 real. Well, 0 real is now being replaced with 2 imaginary. So 23 here. We're supposed to plug in b squared minus 4ac. We're just supposed to decide how many solutions are there. B squared minus 4ac, that's going to be negative 8 squared minus 4 times 1 times 16. That's 64 minus 64, which is 0. So the discriminant is 0, which means that there is 1 real solution. 1 real solution. That's all we got to do for these problems. It doesn't actually ask for what is the solution. It just asks us to kind of describe the solution. 24. Again, same style problem. We're wanting to use the discriminant, b squared minus 4ac. So that's going to be negative 8 squared minus 4 times 1 times 12. 12, if I can write that down right, 12. This is going to be 64 minus 48. And I'm not really sure what 64 minus 48 is, but I know that it's less than 0. It is a negative number. And when the discriminant is, oh, did I just say that wrong? Oh, it's a positive number. Oops, I just went on autopilot there. It's greater than 0, so it is a positive number. There we go. Sorry, it's a positive number there. Whenever it's a positive number, that means there's going to be 2 real solutions. Number 25, I'm thinking this is the 2 imaginary ones. Let's see. B squared minus 4ac is going to be negative 8 squared minus 4 times 1 times 20. That's 64 minus 80. There we go. That one's going to be the negative one. And being negative means that there are 2 imaginary. 2 imaginary solutions. This idea here, the last three problems here where we use the discriminant, we weren't actually finding the actual answer, right? We were just using it to describe what the answers are going to be. And that's an idea that we're going to use later on, where we don't necessarily look for what is the answer, but we look for what kind of answers are we going to get. What are the answers going to look like? All right, 26. We're supposed to solve using the quadratic formula. A is 1, B is 9, C is 4, and we get x equals, and I'm just going to go ahead and plug straight right in. X equals the opposite of b, so that's a negative 9, plus or minus the square root of b squared. That's going to be 9 squared minus 4 times 1 times 4. That's 4ac, all over 2a, which is 1. So negative 9 plus or minus the square root. The discriminant is going to be 81 minus 16. Let's see if I can type that in. 81 minus 16, that gives me 65 over 2. The 65 is a pretty big number. We can break that apart into a 5 and a 13. 5 and 13 are both prime, and there's no duplicates, so we leave it as a plain old root 65. And that's our answer. 27. We need to get this guy equal to 0, so I'm going to add that quadratic term over, and I'll have 0 equals 4x squared plus 3x minus 1. I'm going to plug straight in the quadratic formula. Negative b is going to be negative 3 plus or minus the square root of 3 squared minus 4 times negative 1. That's 4ac, all over 2a, so 2 times 4. Now I'm going to type the discriminant in my calculator. That's going to be, what, 9 plus 16. That gives me 25, all over 8. Square root of 25 is a plain old 5, so negative 3 plus or minus 5 over 8. And because that 5 is a nice integer, I can break this apart into its two parts. Negative 3 minus 5 over 8, and negative 3 plus 5 over 8. The top one here gives me negative 8 over 8, which is negative 1. And the bottom one here gives me, what is that going to be? Negative 3 plus 5 is going to be 2 over 8, which is going to be 1/4. And there we have our separate answers. Now I'm feeling like I got, is that negative 1 supposed to be right? Yep, I think so. All right. I was getting worried that was supposed to be a positive one there, but I think it is a negative. Yep. All right, there's 27 there. Let's see the next page. Another solve with the quadratic formula. I'm going to subtract that 4 over, so we get negative 3x squared plus 5x minus 4 equals 0. And then going, again, straight into the quadratic formula. X equals negative b, so that's negative 5, plus or minus the square root of 5 squared minus 4 times negative 3 times negative 4, all over 2 times negative 3. Now I type the discriminant into my calculator, so that's 5 squared minus 4 times negative 3 times negative 4. That gives me negative 23, so I'm going to have negative 5 plus or minus root negative 23 all over negative 6. Now prettying this up, we'll have negative 5 plus or minus I root 23 over negative 6. And then lastly, because I have these negatives out front, we're going to try to make that a little bit nicer. I'm going to multiply by a negative 1 over negative 1. Right? If you multiply by the same thing on top and bottom, you're really just multiplying by 1. So this is a fancy 1. I'm multiplying the bottom, and I get just a plain old 6. Whenever I multiply up top, I get a plain old 5. And then whenever I distribute to the second term, it would really change the plus or minus, but it's still going to be a plus or minus. Right? The minus would be a plus, the plus would be a minus, but it's still plus and minus. I root 23 3. And there we go. That's our answer there. The 23, we can't break him apart, so we don't have to. We just leave him as a root 23. 29 here. Is this our last one? Nope, we got 2 more. Let's go ahead and move everything just to the left side. 6x squared minus 4x plus 9 equals 0. Plugging in the quadratic formula, I'm going to have x equals 4, right? Negative 4 plus or minus the square root of negative 4 squared minus 4 times 6 times 9 all over 2 times 6. I'm going to type the discriminant into my calculator. That's going to be negative 4 squared minus 4 times 6 times 9, and that gives me negative 200. So I have 4 plus or minus root negative 200 all over 12. Now negative 200, the negative becomes an I, so we can go ahead and write our next step down, or we can start it. 4 plus or minus I, we're going to have a root. We'll have a 12 in the bottom. We need to figure out what goes right there and what goes right there. The 200, we can break that apart to be 102. 100 is 10 and 10. And we could break those 10s apart, but I'm just going to circle them right now and say they go outside. And then the leftover 2, he goes inside. Now, kind of like before, we've got a 4, a 10, and a 12. I think we did this a couple problems ago. We can reduce these all by 2. Now, what technically we would be doing here is we pull out a 2 from the top, and that would be 2 plus or minus 5i root 2 all over 12. Right? So I factored out the 2 on top, and then I would cancel the 2 and the 12 like they were a fraction together, like 1/6. So I'd have a 6 in the denominator, and then 2 plus or minus 5i root 2 up top. Oops. And there we be. That's going to be our answer there. A common mistake would be to try to reduce the 6 and the 2 again, but you can't because of this 5. That 5's not even, so you can't reduce them again. Alrighty, number 30. I'm not going to do this whole problem here, but what we can do right in the very beginning is we can still divide by 2. Everything is even, and that just gives us some smaller numbers to work with. So we'd have x squared plus 6x plus 9 equals 0. Right? So that's going to be our last problem there to do. And I'll let you guys try that one out. All right, that is all of the quadratic formula. Here, just as a side note, I'm thinking that you should get, what, negative 3 as an answer? You know what? Let's go ahead and do this one anyway. We're going to have x equals negative b, that's negative 6, plus or minus the square root of 6 squared minus 4 times 1 times 9, all over 2 times 1. The discriminant ends up being 0, right? 6 squared is 36, 4 times 9 is 36, so he zeroes out. And we get negative 6 plus or minus 0 over 2. Well, plus or minus 0, that's a nonsense statement, right? It's just 0. So negative 6 halves, which gives me negative 3. And that's going to be our answer. Right? The value in doing that problem, I wasn't going to do it, but I realized that this discriminant gives us a 0. So that was a little bit different than any other problem that we did. All right, now I'm finally done. That is the quadratic formula. Make sure that you know the quadratic formula. Let me see if I can pull it back up just for the very end. Oops, did I go too far? Nope. There we are. Oops, it's gone. There it is. Make sure you get that memorized. All right, that's it. That's the quadratic formula.